Good afternoon. My name is Luis Luro. I'm I'm from the group that is in charge of the project of the dynamometer, and my subsystem is the emergency brake system. And today I'm going to present to you phase C1. The agenda for today is first I'm going to show the interface diagram, the design studies, then design to specification and drawing, the verification of each critical component, and my project plan for custom 2, which includes C2, phase D, phase E, and phase F. The interface diagram for the emergency brake system. A dynamometer uses a roller with an angular velocity of 319.18 radian seconds and an inertia of 244.28 pounds per feet square. The brake system will be a disc brake system with a rotor diameter of 15 inches and needs to stop the roller in 4 seconds or less, with the hydraulic lines having a maximum pressure of 1,200 psi and the ceramic pads a friction of 0.31. Find the caliper that should fit these parameters and determine A. The angular deceleration required to stop the roller in 4 seconds or less. B. The required braking torque. C. The force needed to stop the roller. D. Compare the pressure calculated with the max pressure that a ceramic pad can withstand, which is 300 psi. E. The hydraulic pressure of the line. And F. Confirm that the roller will stop in 4 seconds or less. The critical components, as mentioned in phase B, are slotted disc rotor, a fixed caliper, a drift e-brake lever, a tandem master cylinder, ceramic pads, and also hydraulic lines. For the design study, this is this is the analysis made with using our interface to make the calculations from A to E, as previously mentioned. Here we have the given parameters and the dimensions when using a Willowwood caliper, which has 4 pistons, and the ceramic pad. First, we, we use the angular velocity given by of the roller. That we calculate the the inner radius, which is A. Then we calculate the the angular deceleration using velo the angular velocity and the time in which the roller has to stop. For C, we calculate the torque using the inertia of the roller and the deceleration that we calculated in step B. Then we calculate the area of the pistons. And notice that the area is always pi times the diameter of the piston squared divided by 4. But since it's a caliper of 4 pistons, you multiply it by 4. Then you have the pressure that is actuated on the pads, as you can see in part D. And when compared with 300 psi, then that means that the brake pad can withstand the ceramic brake pad can withstand the psi, the pressure that will be applied. After that, for E, we calculated the force, the actuating force, and in F, we calculated the hydraulic pressure on the lines, which is 1,006 psi, which is a lot less than which is less than the max allowed by the lines, which was 1,200 psi. And lastly, we made sure that the time was going to be 4 seconds to stop the roll. These are the assemblies basically. Here I'm going to explain more in more detail each one. First, we have the caliper mount uh, with its specific dimensions. This mount will, will be used to hold the caliper in place by using some by using screws, and the hole will be from the chassis to the caliper. The next one is our first assembly, which is the e-brake lever. It has different components. This is used. This is the one that the person is going to use to make the emergency brake system use stop the. Here we have the master cylinder, which is in our case it will be a Woodwood. It's a tandem master cylinder as explained in phase B. This is because that way we can make sure that if there's a leak, the rotor will still be able to stop with the emergency brake. And last, we have our final assembly, which is the disc rotor with the caliper, with the pads, and the caliper mount. As you can see, there are the specifications and the bill of materials. Here we have the bill of materials, a better breakdown. Here we have the number of components, referring to the drawings and made, the name of the component, and the cost. By doing this and taking the cost, we have a cost of $1,330. This is more than the one the emergency brake system had for the budget. The budget for the emergency brake subsystem was $1,200. On the pie chart, you can see how the $1,330 are are dispersed. Now verification, the MOP will be the MOP versus the results, and in which phase was verified. First, we have the easy to operate. This was verified in phase B, where only you're going to be pulling or pushing the mechanical actuator. Second MOP was that the dyno had to stop in 4 seconds or less. This was verified in this phase with the detailed analysis, where we actually approved that it will stop in 4 seconds. Third MOP, the emergency brake system has to be separate from the other subsystem, which is another brake system. And this is what's verified in phase A, because since then it was said, and we're going to use a different master cylinder, different caliper, different disc rotor with different parameters and specifications. The other MOP was normally closed when dyno is not in use. Level will be in down position. That is verified in phase B. The number of critical components, we only have 7 critical components, also verified in phase B. Hydraulic pressure will be less than 12,000 psi. 1200, sorry, 1200 psi. This was verified in phase C1. With the analysis, we calculated that the pressure, hydraulic pressure, will actually be 1006 psi. The last MOP was, as I explained in the last slide, our budget was supposed to be only $1,200, and it's actually $1,330. This was verified in phase C1, and just by looking, we do not we do not comply with that result, with that MOP. The budget, as seen, uh, we can compare the cost of the subsystem emergency brake system, compared with the total budget of the for the dyno. The dyno had a budget of $8,000, which means that my subsystem will cost 17% of the total budget. And lastly, this is the project plan that we have as a group for the next phases, which is capstone 2. And we're supposed to, as said earlier, we send an email to the professor, and that's when, with the date that we're going to do our next presentation, which is phase C2. Thank you very much for your attention. Have a good day.